Let's practice graphing some parabolas. So if we graph this one, f of x equals x squared minus 6, one important thing, my general form is maybe f of x equals a times x minus h quantity squared plus k. And when I compare this here, I see, well, there's none of this stuff, right? There's nothing in front of the x squared. Of course, that really just means then there's really a 1 in front, so I've got a equals 1. But then when we look at this and say, well, this is supposed to have x minus something squared plus k. Well, I see a k at the end. It's negative 6. It's minus instead of plus, but that's okay. There's nothing here with the x squared. Well, there really is. If you wanted to be fancy about it, I could rewrite this 1 times x minus 0 quantity squared minus 6. Right? If your x squared is just by itself, and there's not a number with it in parentheses, well, we just think of that then as being 0. So to graph this parabola, I know since a is equal to 1, that means it's going to be opening up. And I look here to get my vertex. It's just going to be 0, negative 6. Okay? If I plug 0 in for x, 0 squared is 0, 0 minus 6 is negative 6. So we've got 0, negative 6. 1, 2, 3, 4, 5, 6. That's my vertex. That also then is my axis of symmetry, is going to be right here along this y-axis. So to graph the parabola, I'm going to pick two x-coordinates on the same side of the axis of symmetry. I always go to the right, so if I've got here x is equal to 0, if I go to the right I get x equals 1 and x equals 2. So I get 1 squared minus 6, that's negative 5. I get 2 squared minus 6, that's 4 minus 6, which is negative 2. So 1, negative 5, and 2, negative 2. Those would be there. Then I use symmetry to get 2 points on the other side of the axis. So this point is 1 to the right, this point is 2 to the right, so I want corresponding points on the other side. I want to go 1 to the left at the same y-coordinate and 2 to the left. And then I get this nice sort of U shape, bowl shape. I can curve through the vertex, and then it should keep opening up and out. One thing, often when we graph a parabola like this, we're asked to then find the vertex, which we've already found. That's the point 0, negative 6. And sometimes we're asked to give the equation for the axis of symmetry. Well, this axis of symmetry goes up and down through an x-coordinate of 0. There's lots of y-coordinates, right? We've got y equals positive 8, we've got y equals negative 2. The y-coordinate changes, but all along this line, all the x-coordinates are 0. So the equation for the axis of symmetry is x equals 0. Remember, that's also what we had for a vertical line. Any vertical line was just x equals a number. All right, so let's try this one. Again, my general form would be a times x minus h quantity squared plus k. And so here I see that a is negative 1. That means this parabola will be opening down. There's nothing here, but I sort of could throw in a plus 0 at the end, right? That doesn't change anything. And so when I look at this stuff, I see that my vertex, well, it's always, what would you have to put in for x here to make this 0? Well, 3 minus 3 would be 0. So my vertex has an x-coordinate of 3. Well, then 3 minus 3 is 0. 0 squared is 0. Negative 0 is 0. 0 plus 0 is 0. So my vertex is going to be at 3, 0. So I can graph that. There's the point 3, 0. My axis of symmetry is going to go up and down through that point. And then I pick two x coordinates on the same side of the axis of symmetry. So I always go to the right. That keeps me from getting negatives inside the parentheses. That's why I always go to the right. So if I go one to the right here, I'd be at 4. Another to the right, I'd be at 5. So don't forget this negative on the outside. 4 minus 3 quantity squared, that's going to be negative 1 squared, which is just going to be negative 1. And then when I plug in 5, the negative stays outside the parentheses. 2 squared is 4, so I get negative 4. So we get 4, negative 1, and then 5, negative 4. So those are on the same side of the axis. I just reflect them over, and I get 2 points on the other side of the axis of symmetry. And my bowl then is opening down instead of up, which we predicted. So my vertex was at negative 3, 0, and my axis of symmetry is x equals 3. Vertex isn't negative 3, 0. What am I doing? Vertex is at positive 3, 0. Sorry. Because it should always line up with my axis, right? Whatever the x coordinate of the vertex is, that's my axis of symmetry, x equals 3. One thing all these problems are having in common, I'm always getting x squared. We're going to have one at the end that has y squared. That's going to make it horizontal instead of vertical. So one of the things I should sort of notice here is that since it's x squared, that means it's vertical. Vertical. Let's get that looking nicer. All right. My general form f of x is a times x minus h quantity squared plus k. So I look over here. I don't have anything in front of the parentheses. That tells me then a is really 1. That means it's going to open up. This stuff gives me the vertex. The x coordinate is always the opposite of what's in the parentheses. That's because I'm sort of thinking, what would make that 0? To make that 0, I'd have to put in x is negative 2. But if all of that became 0, I would just get a negative 5 then as my y coordinate. So I start at negative 2, negative 5. That would be my vertex. My axis of symmetry goes up and down through that vertex. And then I just pick two x coordinates on the same side of the axis. So if I'm at negative 2 and I move 1 to the right or 2 to the right, I'm going to get negative 1 and 0. So I plug in negative 1 for x. Oh, I wrote down the wrong function here, or it didn't take. Okay, there we go. So I get negative 1 plus 2 quantity squared minus 5. So negative 1 plus 2, that would give me 1 squared minus 5, which would be 1 minus 5, which is negative 4. That didn't write very well that time. So negative 1, negative 4, that would be here. And then I plug in 0. And I get negative 1. So again, I have symmetry. These points are 1 to the right and 2 to the right, so I'm going to go 1 to the left and 2 to the left, and there would be my parabola. It should keep opening outward. I almost started going too far up there. My vertex then is at -2, -5, and my axis is at x equals -2. Well, this one totally looks like my standard form. A times x minus h quantity squared plus k. So my a value is -2. That means it's going to open down. For my vertex, I look at this here. What would I have to put in for x to get 0? I'd have to put in 3. 3 minus 3 is 0. 0 squared is 0. -2 times 0 is 0. 0 plus 8 is 8. That's why that number at the end just becomes the y-coordinate, right? I mean, everything else becomes 0 when you're at the vertex. So 3, 8. I move over 3. 1, 2, 3, 4, 5, 6. Ooh, barely. There's 3, 8, right? Up there at the top. Fortunately, this parabola is opening down, so that's going to be okay. That's also then where my axis of symmetry is. Right there. So I'm going to pick two x coordinates on the same side of this axis of symmetry. So what do we have here? -2 times x minus 3 quantity squared plus 8. All right, so we've got x equals 3 at my vertex, and so if I go to the right, I'm going to get x equals 4 and x equals 5. So I plug in 4. So 4 minus 3 quantity squared plus 8. So that's -2 times 1 squared plus 8. So that's -2 times 1 plus 8. That's -2 plus 8, which will be 6. So if I plug in 4, I get out 6. 1, 2, 3, 4, 5, 6. If I plug in 5, I get 5 minus 3 quantity squared plus 8. So that's 2 squared plus 8 with the -2 in front. So that's -2 times 4 plus 8. So that would be -8 plus 8, which would be 0. So 5, 0. So this is opening downward. It's also going downward more quickly than a regular parabola. It's a narrower parabola. I would have corresponding points on the other side of the axis of symmetry, so I sort of just flip them over, and that would be my parabola. It keeps opening outward and downward. Okay, so my my vertex is at 3, 8. My axis is at x equals 3. One more example then. This one I have y squared instead of x squared. That means my parabola is going to be horizontal instead of vertical. So what I have here, it's in theory my general form is standard form a times y minus k quantity squared plus h. And so in this a value, instead of opening up or down, it's right or left. If a is greater than 0, it opens to the right. If a is less than 0, it would open to the left. And so what I see here, a equals 1, so this parabola is going to open to the right. For the vertex, I look at these values here. Be careful though. We would let y be -1, and then we would get x is -3, right? If I plug -1 in for y, -1 plus 1 is 0. 0 squared is 0. 0 minus 3 is -3. So my vertex, we always have to list x first. So my vertex would be -3, -1. And my axis now will not go up or down. My axis will go left and right. So when I'm going to make my chart, I'm going to have to be a little careful here because my x is what something is made of, right? X is computed based on y. So I'm going to pick y coordinates and then plug in to figure out what x is. So here I'm starting at the vertex. To get 2 points on the same side of this axis, I can't go left or right, I'm going to have to go up or down. So I'm going to go up, and instead of y being negative, I'm going to have y equals 0 and y equals 1. So then I plug those in over here, and when I plug in 0, I get 0 plus 1 quantity squared minus 3. That will be 1 squared minus 3, which will be 1 minus 3, or -2. So this has an x coordinate of -2 and a y coordinate of 0. And then when I plug in 1, I get 1 plus 1 squared minus 3. That will be 2 squared minus 3, which will be 4 minus 3, which will be 1. So I've got an x coordinate of 1 and a y coordinate of 1. And then with symmetry, if I have a point above the axis, I'm also going to have one below. So my parabola will be opening to the right, like this. So my vertex is at -3, -1. My axis now is horizontal instead of vertical, so it's not x equals a number, it's y equals a number. And that axis is at a y coordinate of -1. So horizontal parabolas are very similar, you just have to be careful with what's x and what's y.